In this video, I'll be solving with problem 543, diameter of binary tree. Given the root of a binary tree, return the length of diameter of the tree. The diameter of the binary tree is the length of the longest path between any two nodes in a tree. The path may or may not pass through the root. Nice. So diameter of this one is interesting. So there comes two. Oh, it's actually not that hard. So two things came to my mind. So at least diameter is of size length, because length is between height, so height of the tree. So from the root node to the end we have height, and everything else could be shorter, but in any case if I'm correct, and I think I am correct, yeah, so the longest diameter will be between nodes left side depth and right side depth. So in this case I will take one and check it's 2, here is one that's 3, and so on. So recursively I will call, and then I'll just take the max. Okay. So how am I going to find the depth? Well, the same thing. So okay, well, height, and I will give I'll have root. So the biggest height will be, if not root, then I just return. If I have root, then left is, I said 1 plus height of root left, right is 1 plus height of root dot right. And I return left right. So height left right. Let's highlight that and I return left right. And now I just need to find, so best is equal 0. Or maybe I would now need also delay. Let's do it like this. It will be easier a bit for me. Diameter. Let's call it root. So from the node it will be height left right of root. From left it would be height left right from the root dot left, and right will be height left right from root dot left. So if it's greater than 0, then left plus equal 1, because I don't want to count it twice. If right is greater than 0, then right plus equal 1, because if it's 1, but then it's already counted, so yeah, I don't actually need to do this. Or I actually have to do it, because let's do it like this. So if right was non-existent, then I would need to, so if left is equal 1, then left minus equal 1. If right is equal 1, then right minus equal 1. This is what I want to solve. I guess. Diameter node. I guess this. I messed it up now. I kind of messed it up. So node is let's do it like this. So best is equal 0 while current dot left current is root. So while current so while current while current should I do a queue? I don't want to do a queue. Why does this look so complicated? I should have done something recursively that if it can do, it does. Let me do something recursively. So find and I get find diameter call it a root. So find diameter will check what's root d will be sum of height left right from root. And I'll return max of root d find diameter find diameter of root dot left and root dot right and return find diameter of root, something like this. Solution does not have. Should have done this. I'm not sure why. Sometimes I'm pretty bad with this. So why I call it self? I didn't put self as a parameter. I'm not sure. So height left right. Well, I need to return. Okay, I think I totally messed this one up. So yeah, let's this was pretty stupid, I gotta say that. So let's do this from scratch. I'm not sure why I got this much stuck on this one. So I want to find the height from the root, maximum height. Maximum height from the root is if not root, then return 0. Else left is 1 plus height of root dot left, right, is equal 1. Well, I don't need to do summing up twice. Height of root dot right. Root left, root right. And now I return 1 plus max left, right. Okay. Next step, I have find dm. It will get a root as an input, and I will need to check left subtree is height of root dot left, right is height of root dot right. If left is greater than 0, left plus equal 1. If right is greater than 0, right plus equal 1. Okay. This is the longest path from that includes the root. Return left plus right. And now I have to check for each node. I need to test this essentially, it seems. Well, then I'll use some kind of queue. Okay, so while q dot append root, while q best is equal 0. So while I have something on the queue, I do find best is max of best and find the diameter of root. Find dm of root. So I'll have something in the queue. I do this. Update the best if root dot left. Actually, this will be, well, let's use node. if node left, then q dot append node dot left. If node right, then append node dot right. This was pretty badly done. And then I'll do recursive once more, because I think I got an idea. So if this, if that, node is q dot pop left, and I don't need to pop, but I don't need q, but never mind. So I go step by step, check everyone, update best, return best. DQ. So 1, 2, 3, 4, 5, 1, 2. Well, since I go root right, I'll return 1. So I don't actually need to do this. This is the problem. Yeah. But this is, I think, too complicated. So probably it will get timed out. Yeah. Okay, at least I did it. How can I do it more efficiently? Oh, this should be done some other way. Yeah, this should be done some other way. I did it like very stupidly. Well, I could just cache this. And if I cache this, I think this will be better. Could pass, yeah. Okay, but okay, I'll leave this one like it is, because I think I'll leave this one as it is. Or let's maybe calculate it. So best equals 0. It just came to my mind, but It's a bit long video, but yeah, just the way it is. So left subtree has this number of nodes, right subtree has this number of nodes. I'll call it dm is equal left subtree has this number of nodes. Well, left has this. I maybe have a 2, that's the question. Okay, if dm is left plus right, that's diameter. Diameter is left plus right, and if left is greater than 0, then dim plus equal 1. If right is greater than 0, then dm plus equal 1. Best is equal max of best and diameter. And actually that's it. Yeah. Not sure why I did it this bad. So I just had to do best return 1 plus max. Yeah, I have to return for recursion, but let's do it like this. So this will be height of root, and I just return best. No. Okay, I'm pretty bad. Why double calculate? I need to check why is this so. Okay, so I did it now. Much better. So I have left is, so I'm here. I have height from root left. One. So it will be height from root left will be why is it double counting? Let me think about it. So when I'm at the root, I check what's my left subtree, and left subtree will call this. This will not be 0, so it will call again left. This will not be 0. It will call again left, and then that will be left will be 0 and right will be 0. So, and already here I return 1. Okay, because I count nodes essentially. So that's why. Okay, got it. Seems I had problems with that. So space complexity, well, has to be height this time. Time complexity, well, we have to pass through all the nodes, so this will be n, has to be n. No, okay, never mind. I guess this is true. Okay. And the other complexity was something crazy, but it passed. Yeah. Okay, if you have any questions, leave them in comments. I appreciate you for following this video, and see you in the next video.